So when you talk about the derivative, now let's talk about the first simple thing, which is considering the slope of a line. Now, when you talk about the slope of a line, is basically given by, if I take this as x1, the corresponding point, if I take y1, if I take x2, and the corresponding point is y2. So slope of this is nothing but y2 minus y1 over x2 minus x1. Slope is y2 minus y1 over x2 minus x1. Now, I can see that this is also change in y over change in x. Now, how much change in y is happening? If I, let's say, change x from x1 to x2, then my y changes from y1 to y2. And their related change is called as slope. Now the context become completely different. Like for a line, if I say that slope is 2, for a line slope is 2, let's say. Now what does this slope 2 mean to us? If I say slope is 2, what it means is that if I say change in y will be 2 times change in x. In simple language, if I say that I change the x value by 0.01, so what the y value will change to is 0.02. So the change in y will be double the change in x. That's the meaning of the slope. So slope is actually also referred as rate of change of one quantity with respect to other. So slope concept as a key concept, when you say, okay, slope is basically 3, it means that y is changing 3 times faster than x. So that's a basic like interpretation of how do we link up the slope concept. Now, how it is linked up with our topic, that is something which we need to watch carefully, like, in terms of derivative, like what is derivative? So now when you talk about the derivative term, now why do we need this differentiation skill? Okay, so now as you can see, if you have, let's say, a curve, now instead of a line, if we have a curve, now you will notice that at every point, if I draw a tangent, like for example, like generally we measure the slope of a curve by drawing tangent at that point. So if I draw the tangent at this point here, let's say the slope of this tangent is coming as something different compared to if I draw a tangent, let's say here. So at every point, the slope is different. Now, how do we tackle with this particular need that, okay, is there any way I can have a formula for that curve so that I can just put some x coordinate in that and I get the slope. For line, the slope was throughout constant. For line, you don't have multiple slopes, but for any quadratic or any particular curve that you talk about, you will always have multiple slope because at every point the slope is changing. Now let's say for example here, if I find the slope here or here or here, every point the slope is changing differently. So what happened is that the basic idea of differentiation is actually by introduction of the same concept but for a curve. Now this is something which might require a little bit of knowledge that we used for the functions like your unit. So let's just talk about this part. And even though it is not explicitly mentioned in your syllabus, I'm still doing this so that you have the clear picture in your mind that how do we get the derivative thing. Now, first thing is that, let's say when you talk about change in y over change in x. Change in x. This is referred as, change in y is referred as dy. Like if I say that change in y is dy over change in x is dx. So change in y over change in x. So now when you talk about the change in y over change in x is dy is referred to change in y and dx. So this is something that we call it as nothing but the derivative notation. Now when I say dy is like rate of change of, it's referred as rate of change of y with respect to, with respect to, with respect to x. Now this dy by dx is also referred as f dash x. That f, if there is a dash here, it means they're asking us to find out a derivative function. Sometimes it is referred as y dash also. So sometimes it's referred as the, if they put a y and they put a dash, it means that they're asking for slope function. So I'm just going to just do quickly, like see the idea of the slope function. Okay, now here what we have is, let's say consider this is a point x and this is corresponding point is, let's say, f of x. This is x and corresponding point is f of x. And now if I take, let's say, another point, which is, let's say, x plus h, my corresponding y value will be f of x plus h. So correspond, if I have x, this point is f of x. Let's say x plus h, if I take, the corresponding value will be f of x plus h. Now what we have is, if I take the slope here, if I find out the slope of this chord, okay, this line segment, let's say this A and this is B. So slope of this, if I take, slope will be f of x plus h minus f of x over h. Means x plus h minus x, basically like y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. So this x and x get cancelled. And what we have is, we have f of x plus h minus f of x over h. So this is now my slope formula. This is the slope formula for this chord. But I don't want this. This is what I don't want, because this is representing slope of a particular chord joining 2 points. Now my need is that to get me the slope at a fixed point, slope at a point, not the slope of a chord. So what we restrict is, if I put a limitation, okay, if I put a limitation that, okay, limit, if my h value is very close to 0, f of x plus h minus f of x over h. What happens is that, if you notice that if my f of x, the h value is close to 0, for example, if my this x coordinate is, let's say, 2, and this x coordinate is, let's say, 2.000000000000, so many zeros, infinite zeros, and then you have like something like 1. Now in that case, actually these 2 points which you can see with like magnified view will be actually the almost the same point. Now if I probably draw it like this, it'll be something A here and B will be something here. Now in that case, if I draw the chord, it is nothing but the tangent to the curve. So this chord that you see here is actually going to be looking like this if my h value closes to 0. Right? Now if I, for example, if I consider the function f of x equals to x, y equals to, let's say, x. And we all know that slope of this line is 1, because y equals to mx. When you look at m, here is 1, so m equals to 1. Now the logical part is that, what is the evidence that we have? Is there a way that we can show that for this curve my slope will be always 1? For this line, my slope will be always 1. So we use this formula, okay? So now, for example, first let's say f of x has been given to us as x. Now, if I want to find out, let's say just randomly, I'm giving some examples to refresh the knowledge of function. So f of 1 will be 1, f of 2 will be 2, f of let's say t will be t, f of x plus h is going to be, in place of x, you replace x plus h. So my f of x plus h value is nothing but x plus h itself, according to this function. So that comes out here. So according to this, my slope function will be, there is a limitation over h, that, okay, h should be close to 0. F of x plus h that we just got is nothing but x plus h minus F of x is nothing but x itself, x upon h. X and x get cancelled. And if you divide h with h, everybody knows that the slope is 1. Everyone knows that the answer is 1. And that's the reason you get the slope as 1 for that particular line. So now let's say if I have to take the same example for a line 2x plus 3. Let's say I'm doing the derivative for y equals to 2x plus 3 now. So let's say y equals to 2x plus 3 is my function. So everyone knows that the slope is 2 here, but let's see how it comes. Okay, so I'll just go back to the same thing here. I'll first find out, what you got to do is very simple step is to actually do f of x plus h. Now, if my f of x is 2x plus 3, f of x plus h, you just replace wherever you have x, you replace x with x plus h. So 2 times x plus h plus 3, which becomes 2x plus 2h plus 3. Now what I'm going to do is, I'm just going to plug this value here. So let's see what do we get is basically this derivative will become, this is, I'm going to keep it aside. So here my f of x plus h is 2x plus 2h plus 3. That's f of x plus h minus f of x is 2x plus 3, which is this one, over h. This is in the formula. Now, if you subtract these two things, what do we get is basically, what do we get is, let's say, limit h tending to 0, h, this is called h tending to 0. You open up the brackets, so 2x plus 2h plus 3 minus 2x minus 3 over h. 2x and 2x get cancelled, 3 and 3 get cancelled, h and h get cancelled, and as a result of this, you see the slope is, irrespective of any x value, the slope of this line is coming as 2, which is obviously the slope is 2. Now, here when you look at the interesting point is that, like, for example, if I consider a curve, which is x squared plus 4x. Now, if I just look at that, every point, you can see the slope is being different. For a line that we did just now, you could see that the slope was like constant for that line, 2 or 1. But now you can see that at every point, you can see this dy by dx value. If I move the tangent at every point, it is different. It is different at each and every point. You can see that here. So that, and now the challenge that is lying is that how do I find out the slope formula? Is there a way? Okay, technically I'm getting it. Like with technology, I can get it. But is there a way that we can find out a formula for this particular curve? Now, what I would do is I would now take, let's say, instead of x squared plus 4x, I would start with x squared function. Now, when I sketch, let's say, tangent here, if I sketch tangent, you can see the slope is 0. It goes on changing at every point. Now, let's try to find out a slope formula and verify using technology. So now my function is here, f of x is x squared. And with the slope formula, which is dy by dx, which is slope formula, I would write down in the beginning so that we are like understanding the derivative is not a Big Bang theory. It's just about, it gives us a slope at any given point. At what rate your y changing with respect to x. So that is nothing but f of x plus h minus f of x over h. And once again, here the limit is that h should be close to 0. Now let's just start with first finding each values, because we already have f of x, so that goes straight away here. But now if I want to find out f of x plus h, now f of x plus h, we all know will be, replace this x with x plus h. So if I replace that x with x plus h, it will be x plus h the whole square. And now it'd be x squared plus 2xh plus h squared. That comes out as a f of x plus h value. And now I'm just going to put is that value out here. So what becomes is the slope formula for us is x squared plus 2xh plus h squared minus x squared. That's your f of x. This is f of x plus h. This is f of x over h. And obviously the condition is that h should be close to 0. So now once again, you can see the h terms get cancelled, x, x, x squared term get cancelled. And what we got to do is take h common, okay, in the numerator. So if I take h common from here, so if I take h common, so it is 2x plus h over h. And if I cancel it out, what we get is 2x plus h. And now if I take here, because h is such, so our expression is now limit is basically h tending to 0, we got 2x plus h. Now, since h is such a small number, h is close to 0, what happened is that this expression becomes 2x. Because if I add a number that is close to 0, like infinite zeros, and if you add to 2x value, which is like a big number compared to 0.0000, something like that, it is going to come to 2x. Now, you can see that for a quadratic, it is not coming as a fixed value. It is coming in terms of x. So if I wanted to find out, let's say, the slope of this tangent being drawn at, let's say, x equals to 2. So in that case, your slope will be, dy by dx will be 2 times 2, which is 4. And let's check out whether this answer is true or not. So if I draw the tangent at, let's say, 2, you can see that the slope that you're getting here is 4. Now, you just input any x value you want in this formula that you got, the 2x formula, you will get the slope for this particular quadratic. So now, for example, if I take 0, the slope will be 0. Now, if I take, let's say, minus 2, so according to minus 2, the slope is coming negative 4. If I take x as negative 2 here, I'm getting negative 4 again. So this is the backbone, or this is the basic building block of any differentiation unit. Okay, the derivative is representing the slope formula for that particular curve at any given x value. So now let's say, now I want to find out a formula for, let's say, x cubed plus maybe 2x squared. Little challenging one, let's do. And now, since I know that the answer for this is going to be something like that, 3x squared plus 4x, I know this is the answer, and I would like to, like, explain the link after I do with this expansion. So maybe first, let's say I would start with just x cube formula, x cube derivative, so that the answer for x cube you will get, should get, is 3x squared. And previous one, what we got was the derivative x squared. When we did x squared derivative was 2x. That's what we got. And now let's see how we get x cubed derivative as 3x squared. So obviously f of x plus h is going to become x plus h the whole cube. And if you open using Pascal's triangle, it'll be x cubed plus 3x squared h plus 3xh squared plus h cubed. So this is the formula for f of x plus h. Now, when I do this substitution out here, it becomes x cubed plus 3x squared h plus 3xh squared plus h cubed minus, let's say this is going to be x cubed here. So x cubed and x cubed get cancelled. Now you take h common from here. So if I take h common, you get 3x squared plus 3xh plus h squared. And this h and this h should be striked out every time. Okay, so now 3x squared plus 3xh plus h squared. Now all the terms that contain h, because this is close to 0, I can ignore them. Obviously 0 squared will be also 0. So you can see my derivative formula that I get is 3x squared. So you can see that now expression for x cubed that we got is 3x squared as an evidence here, using something called, this is called the base principle or first principle for differentiation. So let's say if you have got f of x plus h, because that's the value we'll need. So x plus h the whole squared plus 3 times x plus h plus 5. So this is the f of x plus h value. We obviously replace x with x plus h. And you get is x squared plus 2xh plus h squared plus 3x plus 3h plus 5. That's my f of x plus h, and this is f of x. So what we're going to do is now you're going to plug in the formula for the derivative function. It'll be the limitation is that h should be close to 0, and f of x plus h minus f of x over h. So f of x plus h is this value. So I'm just going to write down as it is. So it'll be x squared plus 2xh plus h squared plus 3x plus 3h plus 5 minus f of x. So f of x is this. So it'll be minus x squared minus 3x minus 5 over h. So this x squared and x squared cancel, 3x and 3x cancel, 5 and 5 cancel. And so what you're left at the end is, obviously here you put the limitation h is close to 0. So you get h if you take common, so you get 2x plus h plus 3 over h. This and h can get cancelled. Now if you see limit h tending to 0, this part is close to 0. So my final answer that comes is 2x plus 3. So 2x plus 3 is the slope formula for this function. So if I see slope formula for this is 2x plus 3. So if I want to find out the slope at x equals to 1, you just plug x as 1 here and you get slope is 5 for this particular curve. So now there are some observations that we have that leads to a particular formula. Now we just did the derivative of, so my function, like here if my function was, let's say f of x, and I have done f dash x. So what we notice is that when I did first the derivative of x was 1, derivative of x squared we did was 2x, derivative of x cubed we did was 3x squared, and derivative of x to the power 4 when you do, actually if you try doing that, it'll be 4x cubed. Derivative of x to the power 5 if you do, it'll be 5x to the power 4. Derivative of x to the power 6 if you do, will be 6x to the power 5. So if I generalize that way, if I go on doing that way, if you have x to the power n function, the derivative of that will be x times n to the power n, x to the power n times x to the power n minus 1. So this is the formula for derivating x to the power n. So if your function is y equals to x to the power n, the derivative formula for that will be n x to the power n minus 1 for any particular expression. So now we'll just go to the, let's say something similar question as previous example, and let's try to see how come your answer was, let's say we had x squared plus, let's say 3x plus, let's say 5. This was my question that we, let's say, just recently did. Now, similar question. If now I apply this formula, okay, for the function f dash x, if I use instead of x, if you have x to the power n, the derivative is nx to the power n minus 1. Now, what I do is, if you have derivative of x squared when you're doing, okay, so here the n value is 2. So n value, if I do the derivative of x squared separately, the n value is 2. So it is, if I compare, the n value comes to be 2. So if I do the derivative of x squared, it will be 2 times x to the power 2 minus 1. So I'm just going to use this formula, which is nothing but 2x. So the derivative of x squared is 2x. Now coming to the second part, how do I do derivative of 3x? So when you see a constant multiplied with a variable, don't touch that constant, okay? Don't, just leave it aside. So when I do derivative of 3x, I can just take 3 outside and do derivative of x. And if you do derivative of x, here the power is 1. So it'll be 3 times 1 x to the power 1 minus 1, which is 3 times x to the power 0. And that's why the derivative of 3x that you get is nothing but 3. And last part is, if you have a constant separately, the derivative of that constant will always be 0. If a constant is alone, here also there was a constant, but we didn't make that derivative 0, because it is multiplied with x. So you did x derivative and then you multiplied with 3. So you get the answer as 0. So your final answer that you get for this expression, dy by dx for this will be, derivative of x squared is 2x, derivative of 3x is plus 3, and derivative, this is 0. So answer is 2x plus 3. And that's something what we got using the first principle as well. So this is how you use this particular formula. And now let's take some more examples. So now let's say I wanted to find out the slope formula for this particular curve. Now remember that whenever your question is like, okay, of the format x to the power n, then only you can apply that formula. You can see here is in the denominator. You can't straight away do that formula in the denominator. Some students make this mistake. They'll say, okay, 4 as it is, and then they'll do 3x squared using that formula which we learned, which is going to be wrong. So please do not do this. What we will have to do this is, we need to make sure to it that this is first written as 4x to the power negative 3, because simple indices rule. I'm not still doing the derivative. I'm just modifying the structure for us to get to the x to the power n format. So 3x squared minus 6x to the power 5. So now when you do the derivative here, when you find out the derivative function for this one, you get dy by dx. As you see that there's a constant here, you keep it as it is, the 4 as it is. Now, n value here is negative 3. So negative 3 x to the power negative 3 minus 1. So n x to the power n minus 1 plus 3 as it is. X squared derivative we just did, so 2x to the power 2 minus 1. Minus 6 as it is, x to the power 5 will be 5x to the power 4. So if you simplify, this will be negative 12 over x to the power 4 plus 6 over 6 times x basically, and minus 30x to the power 4. So this becomes the slope formula for this particular curve, given curve. So in this one, what we first do is that you can see that the root x is in the denominator. So first what we do is we just modify the equation a little bit. So it will be 3x to the power half and plus 5x to the power 8 as it is. This becomes obviously equals to 3x to the power negative half if you bring it up, and plus 5x to the power 8. Now, if you apply the derivative rule, it becomes 3 times negative half x to the power negative half minus 1, because like n x to the power n minus 1 plus derivative 5x to the power 8. So it'll be 5 times 8x to the power 7. So 5x, 8 times x to the power 7. So this becomes negative 3 over 2 x to the power negative 3 over 2 plus 40 x to the power 7. So that's the derivative of the first particular equation. So that for the next one, what we will do is we can't do directly any straightforward formula. So what we'll have to do is we'll have to first expand this using a plus b the whole squared expansion. So let's see firstly how do we use a plus b the whole squared. So 3 over x the whole squared plus 2 times 3 over x times 2x plus 2x the whole squared. So a squared plus 2ab plus b squared. So it'll become 9 over x squared plus 2 3s are 6, 3s are 2, 6 2s are 12. X and x get cancelled. So this answer is only 12 and plus 4x squared. Now, when you do the derivative for this function, first you have to bring it up. So still this is the y equals to. So 9x to the power negative 2 plus 12 plus 4x squared. Now here what we do is you will do the derivative. So dy by dx using 9 as it is. Now negative 2. So n is negative 2. So negative 2 x to the power negative 2 minus 1. So n minus 1 plus 4 as it is 2x to the power 2 minus 1. Now this becomes negative 18 x to the power minus 3 plus 8 x to the power 1, which becomes negative 18 over x cubed and plus 8x. So that's the derivative formula for the given function. So dy by dx is this. So in C part, when you see, the common mistake that students do is that they do derivative numerator over derivative denominator. That's something which is wrong. So we have the rules for these, which we'll be learning next class. But what we have is, let's say if your y equals to x squared plus 4x plus 3, and you can isolate here. You have to bring the equation in this format. So I would do is x square over x to the power 6 plus 4x over x to the power 6 plus 3 over x to the power 6. So our first step is to modify the things like this so that we can get a simpler form. This become x to the power negative 4. This still the function modification. This will become 4x to the power negative 5 plus 3x to the power negative 6. And now you do the derivative. So when I do the derivative, this will be negative 4. So my dy by dx will be negative 4 x to the power negative 5 plus 4 times negative 5 x to the power negative 6 plus 3 times negative 6 x to the power negative 7. And if you simplify this, like which comes out to be negative 4 over x to the power 5 minus 20 over x to the power 6 minus 18 over x to the power 7.
Sir,
So that's the derivatives.
is it okay if you just